And today I want to take us across questions that wonders on latitude and longitude. But before we go ahead, I quickly want to say here that if you like what we do in this channel, please subscribe to the channel, uh, hit on the notification button, drop questions on the comment section, like the YouTube channel page. Um, if you have areas in mathematics where you would like us to address, you can put it on the comment section, send a question across. I'll do a video recording solution and paste that as well on this YouTube channel. So right away, I'll take us across some things we need to know on latitude and longitude, so that we'll also find ways to solve problems with this. So to address this topic, we'll consider the Earth as a spherical object of this nature. Let's consider the Earth as a spherical object of radius. The radius of the Earth here is 6,400 kilometers. Um, we have to consider the polar axis of the Earth. The polar axis here, we have the North and the South Pole. Then we have the equator that runs from the east to the west, the line of the equator. Then, of course, we can talk about the Great Circle, which is something closer like this, okay, and then comes like this. Then, there is no how we would discuss this without talking about the meridian. This is the meridian, and the lines of longitude comes this way. The lines of longitude are lines parallel to the Greenwich meridian in London. We also look at small circles, or what we call parallels of latitude. Small circles, or we call them parallels of latitude. My circle is not so perfect. It's just a sphere here. You have the sphere. Here you have this is your longitude, your line of longitude. This is the meridian. You have your meridian here. The lines of longitude they are just east or west of the Greenwich meridian. And you have a small circle here. This is just a small circle. Um, this is the great circle here. The great circle. And a few things that we need to know. At least we know about the cardinal points of the Earth. There are important things we have to note for us to be able to address questions on latitude and longitude. Now, first to note here is that the lines of longitude, the lines of longitude, the lines of longitude are measured east or west of the Greenwich meridian in London. The Greenwich meridian. Secondly, the parallel of latitude. The parallel of latitude, which you can also call the small circle. The parallel of latitude. The parallel of latitude are measured. They are measured north or south of the equator. North or south of the equator. And again, another point to note is that the radius of the Earth is approximated at the radius of the Earth is approximated at 6,400 kilometers. Why do we need all of this? We would be required to find points on the Earth's surface or distances along the great circles or small circles, distance along the small circle, along the great circles of the Earth, and on some occasion, on other occasions, you might be requested to find the distance along the lines of longitude, distance between two towns, two cities, 2 points along the lines of latitude. Now, let's say, for example, we have two towns A defined on latitude 40 degrees north, 35 degrees west. This is for town A. And town B is also 40 degrees north, 55 degrees east. If we are to represent this, okay, let's even say the lines of latitude here are 0 degrees. They are both on latitude 0 degrees. These are their coordinates. This is the latitude here, and this is the longitude. Just putting it for short. Here you have the latitude here, and here you have the longitude. Okay. How do we represent these two terms, A and B, on the surface of the Earth? If I take this to be the surface of the Earth, for example, and I am able to draw the polar axis here, that is from the north to the south, and I have the line of the equator. Here you have it from the east to the west here, and I can locate the great circle here. Using these coordinates, I can locate turn A and turn B on the Earth's surface. Both of them are on the same latitude, 0 degrees north, but their longitudes are 35 degrees west. That is, turn A is on longitude 35 degrees west, and turn B is on longitude 55 degrees east. I told us that the lines of longitude are measured east or west of the Greenwich meridian. The Greenwich meridian, yeah, this line here will just help us to note that we are around, we can use this polar axis, the line that passes through the Greenwich meridian here. We can now find this point along the lines of latitude, and that also along the lines of latitude, along the lines of longitude. Then, if we are to determine tan A, the longitude of tan A, we come this way because that the lines of longitude are measured east or west. This is towards the west. We just have 35 degrees. From this point down to this point is 90 degrees. The entire angle here from here to here is 90 degrees. But we just need 35 degrees. So we take something here to be 35 degrees, and we take tan A down here. It's on this longitude here. Tan A here is on longitude 35 degrees, or rather, tan B, this is tan B actually, is on longitude 55 degrees east. Let's say this is 55 degrees. Tan B is on longitude 55 degrees, okay, roughly. Then tan A, this is tan B here, is on the east side, okay, on the longitude, this is on the east side. The tan A is on longitude 35 degrees. Let's say something small like this, 35 degrees west. Remember that their latitude is towards the north, which is why I took it to the north. So this is for tan A. Tan A is here, and it's just 35 degrees west. If we look at this very well, the distance between these two towns on the Earth's surface can be likened to the length of an arc, where this is tan A and this is tan B. Now, when you look at 35 degrees, 55 degrees, the angle subtended at the center here you have 5 plus, this is 0 here, and this is, we give you 90 degrees. The angle sustained at the center by these two terms is 90 degrees. If we are asked to calculate the distance between tan A and B along the great circle, it is the same as saying calculate the length of this arc AB. So the distance between tan A and B is the length of the arc, is the length of the arc AB, which is given as theta over 360 degrees times 2 pi r, where r is the radius of the earth. So if we are to calculate this distance, this will simply, our theta here is 90 degrees over 360 degrees times 2. We take pi here, let's take pi as 22 over 7 times 22 over 7 times the radius of the earth, which is 6,400. With this, we can give the distance between tan A and B, which is the length of the arc AB. Calculating this will give us 10,057, approximately 10,057 kilometers. We'll just multiply this, do this arithmetic operation here, and you get this value.